This is the solid-state drive that everyone is using. Our photos, videos, and applications on our phones are all stored in this chip. Let's open it up and see what it looks like. This is what it looks like. This is called VNAND. It's the best storage technology. With high speed, small size, and big use, therefore, it has completely replaced the old memory cards. And most of the mechanical hard drives on computers, this stack of chips is less than 1 micron in height. Let's zoom in to the size of a single storage unit. After we open it up, we can see that it has 4 layers of different materials. One layer is cut into 8 small rooms which are used to store data. The 8 rooms can store 8 bytes. In the past, with older technologies, a single unit could only store 1 byte and 2 units were needed to store binary zeros and ones. By injecting different amounts of electrons into it, these 3 numbers can change. Depending on the number of electrons, 3 digits can be combined into different bytes and stored in 8 rooms. These bytes are the minimum units that make up your file, and when you store data in them, you are essentially filling them with electrons. A Chinese character occupies 2 bytes or 2 cells. And the electrons stored in each cell can be preserved for 8 to 10 years. If you only read or copy these data, the number of electrons in the room will not change. When you delete your file, all the electrons in the room are forced to be removed, reducing the number of electrons in the room to the lowest state. So how can such a small channel ensure that data reading will not go wrong? Looking at it from a different angle, these storage units are stacked vertically, and this disk storage unit is called a string. What we usually refer to as a string of data. It's a string that originated from here. It has 10 storage units put together. When data is received, only one unit's data is available at the same time. Each unit is connected to a control line. When you read the data, the instruction first sends a read request through the control line to the first unit, and then the storage unit copies the data and sends it through the current pipeline to the top bit line. Then the control line reads the data in the second layer of units. Similarly, each unit goes upward, sending data one by one to the bit lines above. Likewise, this method is used to write data into storage units, with each unit's data entering and exiting a single data line to avoid errors. The bit lines connect each string. Let's take a look at its composition. 10 of these storage units stacked into a string. Through these lines, the string is turned into a page. This is a unit wall. 32 wire strands are placed at the top of the wall for data transmission. An electric current is sent through it. 10 control lines are used to control it. Each control line can access all units at the same time. 6 walls make up a storage area, and 2 blocks connected together are called a pillar. Building the wall layer, this is a unit. This is such a detailed block subdivision, similar to the provinces, cities, counties, and streets on a map, all the way down to the specific address. The 32-bit lines above are like highways leading to the address. At the very end, there is a bit line selector for each line. Their function is like a traffic signal, directing the flow of data in order to allow only one line to permit data to pass at the same time. Similarly, there is such a traffic signal on each layer. They individually command the current channels on each layer and then connect the selectors on each layer vertically with control lines. At this point, all traffic signal lights form a traffic information network, controlling the data flow throughout the entire chip. The height of this chip column is less than 1 micron, and millions of chip columns combine to form a VNAND chip unit. Not only that, more than 90 chip columns need to be stacked to form one VNAND chip unit. This is the height of a piece of paper, so you can roughly understand the height of these storage units. This is the appearance of a VNAND chip. This is the address decoder. This is the peripheral circuit that provides power to the chip. 2 identical chips are connected side by side. Its read/write speed is 500 megabytes per second. This means it can read 63 times. Now, 8 VNAND chips are put together to make a solid-state drive. There is an additional interface at the bottom to coordinate the 8 chips. Through this interface, your computer and phone can truly access the storage unit inside.